Okay, can you hear it now? You can? Okay. Cool. And we'll. Oh, it just wasn't allowing. This has a microphone on it. That's whatever.
Yeah.
Cool. Okay.
I think it might have been the permissions that you had.
It definitely was. But you can still just see this screen.
Yeah.
Okay, cool.
As long as you're on the screen.
If I go away from the screen, you can't see it anymore, or
Let me see real quick. I was really looking at my phone.
you're good.
Nah, you still see it on the screen.
Okay, dope.
Yeah.
Perfect. Cool. All right. How's everyone doing today? Where are we at? Where are we at with it all? Right about here. Some people here. No one looks to be having a bad day. That's good. Wyatt's always the decider.
I'm sitting at home.
Yeah.
I'm just here because
Yes, there is a quiz today. The quiz is 2 problems, and in my opinion, they're really easy. Like, I was looking at the templates for the quizzes from 2 years ago, and I was like, wow, these are tough quizzes. Like, there's so much content on those quizzes. I'm asking 2 questions, and they're pretty simple. Before that, we are going to do some material, just a little bit, nothing too crazy. And then, yeah, the quiz. Again, 2 problems. And like the first one is just 1 problem, like there's no multiple parts. The second one technically is still only 1 part. It asks you to write out the sample space of something and then find the probability of something happening. Pretty easy. It's exactly like I think it's exactly one of the problems we did on Friday. So, yeah. I'm recording the lecture directly through the screen instead of setting up my tripod. 1, because I forgot it, and 2, because I think the quality of it will be a little better. Hopefully, we'll see. Again, those get uploaded to my YouTube channel, and then you can watch those from there. Can't think of anything. Test 1 is going to be next Monday, probably. Next Monday is the 9th, I believe. That'll be test 1. So be in class, please, because I don't know. I feel like it's a little unfair to me if you like skip class and then we have to rearrange some time for you to do that, because then it takes out of my schedule. I used to be like really lenient about that my first semester teaching, and then I'd be here until like 9 p.m. with like remakes and stuff like that, and so I got a lot stricter about it because I don't know. I have a wife and kittens that I want to go home to, so. I don't think there's anything from me about the course in particular. Homework for 8.1, which we finished up on Friday, that's going to be due Wednesday, I believe. I'll open up the homework for 8.2 after class, and that will be due probably Friday. All the homework for the stuff before the test, which is going to be up to 8.5. So 8.1, 8.2, 8.5, all that beforehand. We do 3 and 4 afterwards for some reason. All that homework will be due before class on Monday, like just before the test on Monday. With that being said, if you are OAA or do testing with testing services, please make sure to go ahead and put that request in so that I can get the test made and submitted. Oh, let me take attendance. I forgot that. Let me see if there's anyone in here. People. Just Wyatt. Okay, cool. That's fine. You want to do anything fun over the weekend? Was there like a big like Greek thing this weekend? No, I just saw white women in tiny dresses for no reason. I was going to Evolve, and a group of like 20 girls, like, and it was freezing outside, wearing just like mini dresses. We're all going to tracks with a bunch of guys in suits, and I was like, rough. You know what? Whatever floats their boats. I can't hate. If they're having fun, they're having fun. I can hate though, a little bit, like you're paying for friends, basically. I don't know. Some part of it I get. My mom wanted me to join a frat so bad. Do I look like frat material though? Like if I was in a frat, I'd probably be Uzma Kappa from Monsters University, you know, all the dorks. You don't think so? No. Well, I appreciate you lying to me. That's very nice.
I'm not fine. Yeah.
I want to take attendance. That's what I'm gonna do. I went to St. Louis yesterday. I went to IKEA and impromptu purchased a dresser and a bookshelf. Very happy with those decisions. And had Swedish meatballs at the food court. Very happy.
3 hour drive.
1 hour and 54 minutes, actually. Okay. Samantha's not going to be here. Easton. Easton. Garrett. Nolan. Right there. Benton. Jenna. Rylan. Right there. Mateo. Over there. Gabby. Is back there. Charles. Lizzie. Lizzie's back there. Brandon is not here. Ellis.
See weird, but I have my car dispense. I love this.
Kate there. Arisha is here. Carter is here. Abby right there. Clayton right there. Noah right there. Yvette back there. Logan. Logan not here. Angel. Right there. Sydney's here. Wyatt's here. Cannon. Cannon's over there. Mustafa's here. Callie. Emily's here. Liam over there. Cameron is here. Jamie is there. And Evans is here. And now Logan is here. Cool. I'm trying to get there. I've got like 60% of the class down or so. I can kind of pick you out, but I'll keep working on learning y'all's names. Cool. All right. So like I said, we have a quiz today. Pretty straightforward quiz. Brandon. It's going to be 2 problems. Basic, the probability stuff that we've talked about over the past couple days. Nothing critical. Some things that I'll note. Yeah, a couple things. What am I thinking? Remember the difference between combinations and permutations. Combinations, right? Blank, choose blank, is if the order doesn't matter. For example, if I want to pick groups of 3 people out of here, and I don't care about the order of the group, then it'd be however many of y'all choose 3, right? And there's different ways to compute those, or you can put it in your calculator. Your calculators all have the ability to compute those. On the quiz, there will be a question about combinations or permutations. You can just write out the notation like blank choose blank or blank permute blank and leave it as that. You don't have to give me a number for that. Cool. And then like the counting principle, remember that the total options are, if I have multiple things I have to choose from, it's the first number of options times the second number of options times the third number of options, and so on and so forth. So for instance, if I want to see how many 4-digit numbers there are, right? I have 10 choices for the first times 10 choices for the second, 10 choices for the third, and 10 choices for the fourth. And that makes sense. There's 10,000 4-digit numbers going from 0000 up to 9999. Just works out like that. What else? Remember that the Sample space or the event space is all possible options just written out. For instance, if I wanted to randomly pick someone from this room, the sample space would be everyone in this room. Each person is their own element in that sample space. And then I just pick randomly from that. Or if I'm flipping 2 coins, right, there's 4 possible outcomes. Heads, 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 tails, tails, heads, tails, tails. Those are the 4 possible outcomes. And so your sample space or your event space would be those 4 outcomes, just written out. Cool, cool. And lastly, probability of something happening is just how many ways it can happen over how many total possible outcomes there are. For instance, in the flipping of 2 coins, there's 4 possible outcomes. If I ask you what's the probability that they both land on heads, well, that's 1/4, right? Heads, heads is one of those 4 possibilities. So the probability of doing that is 1 in 4, which makes sense. If I have 1/2 chance of flipping heads, 1/2 chance of flipping heads, multiply those together, 1/2 times 1/2 is 1/4. Cool. All right. Any questions about anything before we dig into some union, intersection, and complements of events? All righty. No, I'll turn the light off. Or, yeah, let me, if you don't mind. All right, cool. So we're talking now, we've been talking about, or at least on Friday, we talked about kind of how sets are going to start being used for probability, right? The sample space is the set of all outcomes. So now we can talk about probability of something happening in terms of like the intersections and unions and complements of sets and subsets, right? And that makes it very useful to talk about, maybe something that has too many possible outcomes for us to consider and write out explicitly. We can talk about it abstractly and pick out some of that information from there. Cool. So if A and B are 2 events in the same sample space, so our sample space here is going to be the same thing as when we were talking about our universal set, right? The sample space is all possible outcomes. The universal set is all elements considered. If I want A or B to happen, so for instance, if y'all are the sample set, and I say, what's the probability of me picking a boy or a girl out of this set? Then it would be the union of those 2 populations together. The intersection is and. So if I want to pick a boy with blue eyes, I have to take the intersection of boys with the intersection of people with blue eyes, and I would pick from that population. So those aren't necessarily just one population, right? There's girls with blue eyes, there's boys that don't have blue eyes, but I'm considering just the intersection of that. It says here, consider the sample space of equally likely events for rolling a single fair die. So, right, 1 through 6 is the sample space of what's being rolled. It says, what is the probability of rolling a number that is odd and exactly divisible by 3? Right. So first we want to list out what are odd. The odd ones are going to be 1, 3, and 5. Everyone cool with that? Then what's divisible by 3? I say the stuff that's divisible by 3. There's 2 elements in that one. That's 3 and 6. Now I want to consider both of them at the same time. I'll say odd and divisible by 3. That's going to be the intersection of these 2. And what element is going to be in that intersection? 3, just the element 3. So there's only one element that I'm considering. There's 6 total elements. So 1 over 6, that's 16.7%. That's the odds of rolling a 3. It's 1 in 6, and that's the only element that's both odd and divisible by 3 between 1 and 6. Cool. Now it says here, what's the probability of rolling a number that's odd or exactly divisible by 3? So and was the intersection and right here is intersection, or is the union. So odd or divisible by 3. That's going to be 1, 3, 5, and 6. And then how many elements are there here? Yeah, it's 4. That's not a trick question. There's 4 here. 6 elements in the sample space. So a 2/3 probability or 66.7% chance. Cool. Everyone cool with that idea? If we want to talk about something like both conditions being true, we have to find the intersection. If we want either one of them to be true, we consider the union. And then the probability is just the number of elements in our probability set over the number of elements in our sample space. So there's 6 elements in our sample space. Here, there's 1 element in our probability set. So is 1 and 6. Here, there are 4 elements in our probability set. So 4 over 6 is 66.7% chance. Any questions about this? Any questions at all? Cool. All right. Says the probability of union of events is the probability of A plus the probability of B minus their intersection. And remember, we've mentioned this a couple of times. If I have, let me grab out a piece of paper. Maybe here. If I'm considering this and this, and I want to talk about counting up all the elements in their union, that's counting up all the elements here and counting up all the elements here. So that's, I'll say the number of elements in A union B is equal to, well, there's the number in A plus the number in B, where this is B, this is A. But I've counted the middle part twice. I just like to re-emphasize this point so that we truly understand what's going on here. So I have to subtract out that intersection, right? Because I counted it twice. I have 2 copies of it. I only want 1 copy of that intersection, so I've got to take out a portion of that intersection. Cool, cool. Probability does the same thing, right? Probability is counting the number of ways it could happen over the number of possible outcomes. So the probability of the union of things is the individual probabilities minus the intersection. Cool. Events are called mutually exclusive if their overlap is 0. So for instance, if I'm rolling a die, mutually exclusive events would be like rolling an odd number and rolling an even number. There's no overlap in those 2 categories. They're mutually exclusive events. Says the probability that a random selected person has a given blood type is listed below. Find the probability that person has type A or type O. Remember, the union here is going to be the probability of type A plus the probability of type O minus the intersection of A and O, right, from this rule right here. So this is going to be probability of A is 0.43 plus the probability of type O, 0.42, minus their intersection. I don't know what their intersection is, but someone cannot have both type A and type O, so they're mutually exclusive. What this means is that A intersect O is empty. What is the number of elements in the empty set? 0. So the probability of an element in there is 0. So I get 0.85%. No one, you look confused.
Well, you said 0.85 and 10%.
Good point. Maybe I'll say 0.85 is 85%. 0.85 equals 85%. Thank you. Cool. Right. So again, it says here that they were mutually exclusive, which means nothing overlaps between them. So I can just add them up separately. But explicitly, I want to say that I'm subtracting out 0 so that I'm like kind of reminding myself that I took care of that portion right there. Any questions about that? Any questions about this at all? Says here that we can use this chart to find the probability of randomly selecting a male or a person with O blood type. So again, this is going to be probability male plus probability of type O minus their intersection. Probability of male is 50%, 0.50, plus probability of type O is 0.42, minus their intersection. Well, here's males, here's type O, and their intersection is just where these bubbles overlap. So this 0.21 gives me 0.71 or 71%. Cool. So again, probability of male, it says down here is 50. Probability of blood type O over here was 42.42 minus their intersection. Their intersection was not empty, so I do have to take out this percentage right here. Cool, cool. Note that someone can be both male and have type blood O, thus these are not mutually exclusive. And that's what we saw here. None of the items here are mutually exclusive, right? Nothing has a probability of 0 here. So everything, at least like male, female, and blood type, not mutually exclusive. Cool, cool. All right. Example 4 says refer to the Venn diagram to the right for events A and B in equally likely sample space S. It says find the following, give it as a reduced fraction and a 2 decimal places. So probability of A union B, and it says use both the Venn diagram and the formula to compare answers. Cool, cool. So first I want to count up how many total things I have. It's going to be this 55 plus 15, that's 70, plus 10 plus 20, that's 100 total. So I just want to write that to the side. Total equals 100. So is the probability of these together, well, it's going to be everything that's not outside of these. So there's 15 out here, which means the total of all of this together is 85. Everyone good with that? So this is 85 over 100. Cool, cool. I can live with that. And that gives me 0.85, which is, again, 85%. Cool. Yes?
Did you forget to subtract the intersections?
No.
Oh, no. Yeah.
I did it implicitly, but that's a good point. This should add up to 85. This is 95 in here. Like if I add these three numbers, that's 95. If I subtract 10, I get 85. So that's what I'm doing there. I wanted to do it without the formula. It's kind of hard to do this without the formula, though, implicitly. Like you kind of just use the formula naturally. But we'll do it explicitly, too. Remember that probability of A union B is equal to probability of A plus probability of B minus their intersection. Probability A is 55. And I'll just write them as 55. Everything goes over 100. Probability of B is 20 minus their intersection. This is all over 100. And again, this is 85 over 100. So it's the same thing both ways. The first way I did it without using the formula was recognizing if there's 100 total elements and there's 15 elements outside here, there should be 85 elements in here. So 85 over 100. Yes.
So elements, like number listed, is just the elements.
Yes. The like a notation way is saying this set doesn't contain the element 55, it contains 55 elements. Yes,
I'm confused, because isn't it 55 with 20 minus 10?
that's a good point.
You must be-
And I just recognize that too. Because there's not just 55 elements in A, there's 65 elements in A. You have to include their intersection. Thank you for pointing that out. So 65 here, 10 plus 20 is 30. Then I take out the intersection. Thank you, thank you, thank you. And this is over 100. That is equal to 85. I realized that as I was talking. Thank you very much for pointing that out. So again, I didn't properly use the formula, so that's my bad. I had to consider everything here. There's not just 55 elements in A, there's 65 total elements in A. It just shares 10 of those elements with B. Same thing, B doesn't have just 20 elements, it has 30 elements, 10 of those are shared with A. Cool. Now you talk about the probability of their intersection. That's just this number here. 10 over 100, and that's equal to, 1 over 10, 10%. 10%. Cool. All right. And this one is a little interesting. We could go through and like add up all the elements that are in this, like find out what the complement is and everything like that. Or we could just recognize that it should be 1 minus the probability of the other thing, right? It's basically, what are the chances of something happen? Well, it's 100% minus the chance it doesn't happen, right? The thing either happens or it doesn't. Here, you're either in the intersection or you're in the complement of the intersection, right? If I put together something and its complement, I get everything, right? For example, in this classroom, let girls be a set. The complement of girls is boys. Put those together, you get the entire classroom. This idea here. So here I'm doing the same thing. This is just going to be 100 minus 10 over 100, which is 90%, which is the same thing as 100% minus this 10%. So that's the important thing there. Same thing with rolling a dice, right? The odds of rolling an odd number are 50%. The complement of odd numbers is even numbers, and the odds of rolling an even number is 50%. I put those together, I get my full thing of 100%. Or the odds of picking a prime number between 1 and 10 is, let's see, 2, 3, 5, 7, 40%. The complement of those prime numbers is the composite numbers. There's 6 of those. Technically, 1 is weird. You put those together, you get 100%. Cool, cool. All right. And I think that's where I'll leave off today, because I basically just noted this out. The complement events is 1 minus that probability. So we'll talk about this starting on Wednesday. And now we move into quiz mode. I'll turn the brightness up. Cool. I'm going to go ahead and stop sharing this.